Let's see how we can use Wolfram Alpha to sketch some vector fields. If you just type in plot a vector field into Wolfram Alpha, it'll bring up this little form you can fill out. So first, it asks for the vector field, which we'll put in curly braces. Let me put in the same one from the last lecture, which was the field 1, x. And then it asks for a range of x values and y values, and then it defaults to -10 to 10. And for now, I'll just keep it like that, but we could change that if we wanted to zoom in or out. So let's compute that and see what we get. Okay, so here we get these vectors. You'll notice that the vectors are almost completely vertical in a lot of these spots. And that's because the vertical component is growing faster than the horizontal one. In fact, maybe let me restrict this back down to -5 to 5 and see if that maybe gets us a slightly nicer picture. Because kind of what's happened is that the middle of the plot has become kind of washed out from the fact that the vectors on the outside are so big. Okay, that's a little bit better maybe. So now you see that in these first few columns, you have vectors that have some small horizontal component, but a pretty large negative vertical component. Then when you get to x equals 0, the vectors are small and perfectly horizontal, and then they kind of switch direction. And actually, one nice thing that you can kind of visualize from this is that if you think of this as a fluid flow, if you were to release an object somewhere and let it just sort of follow the arrows, it takes a path that looks like it might be roughly parabolic. Okay, let's look at some other examples. What if we change that first component from 1 to -y? Now we get this kind of circular flow. Right, what's happening now is that the horizontal component of your vector is bigger the further away from the origin you are, the further up high or down low you are. It's pointing left when you're up above it and right when you're down below it. And you just see this nice kind of circular suggestion here. What if we kind of turn that around? What if the horizontal component is just x and the vertical one is just y? Then what do we get? Well, now we get this sort of radial vector field. So, for example, if you're standing at the point 2, 2, then the output is the vector 2, 2. So that tends to point you even further away from the origin. And the vectors are getting bigger and bigger the further out you get. Now, there's a little trick you can do here. So the vectors here are all different magnitudes, and we see that Wolfram Alpha here has kind of scaled them all down so that none of them are kind of overwhelming the picture. But what if I take x and y and I divide both of those by the square root of x squared plus y squared? Well, the magnitude of the vector xy is the square root of x squared plus y squared. And so dividing through by that is going to turn all of the outputs into unit vectors. And so when I compute this in a minute, I should see that all the vectors are exactly the same length. Okay, now it looks like that does in fact work out. They are, again, all pointing out from the origin, but they're all exactly the same length. Okay, let's just try something a little bit wilder. How about the vector field x plus y, comma, x times y? Let's just see what that looks like. Okay, and so we get these weird kind of swirls. Again, you can kind of try to imagine what happens if you follow one of these arrows along. It's also possible, so instead of doing this in this field here, you can do this just up in the search bar up here. You want vector plot, and then if you give it, say, x plus y, comma, xy, well, then it'll try to do its best job to pick some good range of x and y values for you. And the nice thing about that is that then it also plots some of these sort of flow curves. So maybe let's go ahead and try that again with just a couple of these. If we do the negative y comma x that we had looked at before, here it shows us those nice circular flow curves that we had seen.